Welcome to The Explainer. Today, we are taking the entire mindset of product packaging and completely flipping it on its head. We're moving away from what is honestly often just an aesthetic exercise and treating it like the rigorous engineering and commercial discipline it actually is. We are unpacking the 2026 packaging execution blueprint, and our main goal today, formulating a completely bulletproof packaging inspection standard. Look, if you're involved in bringing a physical product to market, you'll want to consider this your high-stakes engineering masterclass. We're going to build a system together that protects not just your brand's creative vision, but your company's actual bottom line.
All right, let's shatter a common myth right off the bat. Brand teams don't fail because they lack design taste. As the saying goes, they lose time because those packaging decisions are simply made in the wrong order. You know how it goes, right? A kickoff meeting usually starts with these gorgeous reference images and a highly polished idea of what the package should feel like. But let's be real, beautiful 3D renders mean absolutely nothing when reality hits. Just imagine getting that sheer panic emergency call from your warehouse manager because your stunning, custom-designed glass bottles are literally shattering right there on the pallet under their own weight. Ouch. That is exactly what happens when aesthetics drive the bus.
So we really have to ask the hard operational questions right out of the gate. And the biggest one is, does your package survive reordering? Because surviving that first, perfectly manicured custom sample that lands on your desk, that's easy. But surviving the 100,000th unit stacked in some incredibly humid shipping container traversing the ocean for weeks, that is where the true engineering challenge kicks in. We've got to focus on the gritty reality of supply chains, not just the mood board.
To prevent these kind of costly real-world failures, we've pulled a 6-step packaging inspection standard straight from the blueprint. We are going to look at syncing procurement and production, line efficacy and structure, real environment barrier testing, timeline and tooling decisions, total landed cost math, and lastly, compliance checkpoints.
Okay, step 1, syncing procurement and production. This first critical checkpoint tackles the absolute foundation of your manufacturing process, the specification sheets. This is where procurement and production absolutely must be speaking the exact same language. A spec sheet has to prevent interpretation altogether. It's an unambiguous operating agreement, not just a casual design handoff. Just think about the consequences if these two teams aren't totally synced up. What happens when procurement buys a slightly cheaper cap to save, a fraction of a cent, but production's high-speed filling line can't actually torque that specific cap properly? It's a complete disaster. Your spec sheet is your ultimate source of truth. It needs to lay out the material grades, the exact dimensional tolerances, closure compatibility, even palletization logic, so everybody is building the exact same object from day one.
Moving right along to step 2, line efficacy and structure.
Now we have to look at structural design purely from an engineer's perspective, analyzing how that specific structure directly impacts high-speed production line efficacy. A design might look incredible in a CAD file, but physics absolutely takes over once it hits the conveyor belt. These so-called ordinary failures drain massive amounts of money, and we aren't talking about dramatic explosions here. We're talking about minor fractions of a millimeter causing total chaos. For instance, a highly aesthetic curved label panel might look super elegant, but if it causes just a microsecond delay on a high-speed labeler, suddenly you're staring down thousands of skewed bottles, massive rework costs, and crippling line downtime.
Step 3, real environment anti-penetration testing.
Getting into this third area, we've got to define the physical barrier requirements and the actual tolerances of your product formula itself. And we have to do this long before we start picking out fun colors or shapes. We really need to contrast the expectation of desk approval, sitting comfortably in an air-conditioned conference room looking at mockups, with the harsh, unforgiving realities of real-world humidity and heat. If you're packaging unstable formats, anti-penetration and seal stability are completely non-negotiable. Disk approval is essentially just a visual check. Line and system approval means you are running accelerated stability testing on the entire connected system, the bottle, the closure, the liner, the label, under intense, real-world conditions to guarantee that formula actually stays viable.
Let's take post-consumer recycled plastic, or PCR, for example. It's a serious material engineering decision, not just some sustainability marketing claim to slap on the box. Every Earth Day, teams swap out virgin resins for PCR to hit their green targets, right? But here's the catch. PCR behaves differently. It can shrink differently after cooling and create unexpected dimensional shifts. And just a few millimeters of shift on a cap fitment, that means inconsistent opening force or, way worse, outright leakage. You've got to test it rigorously because the material properties directly dictate your seal stability.
All right, step 4. Timeline and mold decision. This step forces us to really stress test our development timelines so we can make highly strategic decisions and, frankly, screen out unnecessary custom mold requirements. This right here is often where smaller or early-stage brands get talked into super expensive custom work. Just look at the capital risk. Why on earth would you lock up your cash in an 18 to 24-week custom mold process when you could literally be market-ready in 4 to 8 weeks by using a stock structure with a brilliant custom finish? Going with a standard bottle or jar, but dressing it up with unique labels, closures, and tactile finishes? That keeps your minimum order quantities hovering around 5,000 instead of a terrifying 50,000. It keeps your capital risk incredibly low while still maintaining a totally premium brand position. Remember, custom tooling is a massive financial commitment. It's not a status symbol.
Step 5. Total landed cost math. Now we tackle the spreadsheet. This is where we have to look past the factory pricing to calculate the true financial impact of your packaging. Listen, if procurement is only looking at the unit price, they are literally flying blind. If they just chase the absolute cheapest offshore unit price, they are completely ignoring logistics delays, punishing tariffs, and massive inventory carrying costs. You could easily face port disruptions or massive damage allowances because that super cheap packaging simply can't hold up in transit. A slightly pricier, structurally superior package actually eliminates rework. It simplifies fulfillment, drastically lowers your damage rates, and ultimately, it drives down your total landed cost. Finally, Step 6, Compliance Document Checkpoints. This final section establishes the mandatory checkpoints. Think of this as your safety net. You absolutely need strict compliance vetting nodes built directly into your development cycles. A casual, verbal assurance from a supplier, or maybe a certificate for a quote-unquote similar item. That represents a massive liability for your company. If you need child-resistant packaging or food contact suitability, you have to demand the exact testing documentation for your specific closure and container configuration immediately. The golden rule here is so simple, but so critical. Never evaluate a supplier's price quote until the compliance documentation for your exact component is definitively proven. If the documents aren't there early, the whole project has zero foundation. So, the big takeaway? Stop designing and start engineering. The ultimate truth of this entire execution blueprint is that the absolute best package is simply the one that survives reordering. A package is rarely just one object. It's a highly connected system of material, structure, logistics, and cost. When you formulate a rigorous packaging inspection standard, one that addresses engineering, sourcing, and finance early on, you build a resilient system. A system that protects both the brand's aesthetic vision and the company's bottom line. You get that beautiful visual impact you're after, but you get it without the late-night operational nightmares. I want to leave you with this final provocative thought. Take a really hard look at your current projects right now and ask yourself, what operational failure is hiding in your next rendering? Are you treating your upcoming launch as just a series of visual choices or as a connected engineering system? Addressing these gritty realities right now is the only way to ensure your product actually scales. Thanks for hanging out with me on The Explainer, and I'll see you next time as we break down another fascinating framework.